homework time. 2.6. Let's do it. So let's go. We got a function. Find the zeros. So remember zeros. X-intercepts, solutions, roots. If they ask for any of these, you're just going to plug in 0 for y and solve. Okay, so 0 equals x squared plus 4. Subtract the 4. Negative 4 is x squared. Square root both sides. Immediately results in a plus or minus. And now the square root of negative 4, let's remember, I'll do it this slow for this one. That is the same as the square root of 4 times negative 1. 4 times negative 1 is negative 4. So that's the same as the square root of 4 times the square root of negative 1. Square root of 4, that's 2. Square root of negative 1, that's I. So this is plus or minus 2i equals x. These are the zeros. 2 of them. Positive 2i. Here, I'll write that for you too, just to make sure you understand. That's the same as saying that x is positive 2i or x is negative 2i. Okay? This and this, both good answers. And then just a quick little note, remember, and a negative inside of the radical ends up being an I outside of the radical, okay? Not a negative outside the radical, not an I inside the radical, okay? Negative in radical, I outside radical. That's the only thing. Okay, let's move it along. Are the zeros also x-intercepts? Ooh, sometimes they are. But in this case, let's think about this. This guy. This is a parabola. Remember, think about the parabola's location and think about the parabola's direction. These two things will usually will tell you how many x-intercepts. This parabola's location is that it's at the vertex of 0, 4. If you're wondering what, how, this is just up 4. Okay. So up 1, 2, 3, 4. Another way to think of it, this is the same as f of x equals x minus 0 squared plus 4. If there's nothing in the parentheses with x, it's 0. And you can get the vertex out of this because this is technically vertex form and standard form. Either way, this parabola is up 4, or you might just remember from the last chapter that plus 4 means it's moved up 4. And then its direction is up because immediately after the equal sign, there is not a negative. So it's up. And this guy, does it have x-intercepts, you guys? No, we don't cross the x-axis, all right? These numbers make the equation 0, so they are zeros, but they are not x-intercepts. All right, here we go. Rewriting. So you guys remember, for number 3, technically this is what you're doing. All right, you're thinking of negative 16 as 16 times negative 1, and you're square rooting each to get 4i. But I'm going to start to do it more quickly. All right, I want you to be able to do it more quickly. The square root of negative 16, that's the same as square root of 16, which is 4. But that negative in the radical results in an I. Square root of negative 11. That's the same as the square root of positive 11, which doesn't simplify. 11's a prime number. That is what it is. But that negative inside the radical becomes an I outside the radical. Now, please look at this. I made dang sure that that I doesn't appear to be in the radical. And remember that you can technically write it as I rad 11, but this is not proper form. And in the future, this might be considered wrong, okay, in future math classes and math tests. We like I to be the absolute last thing. Okay, and then now here we are, rad 12. 12 is not a prime number. So to be sure that it's simplified, I got to do a factor tree. 12 is 4 times 3. 3 is prime. 4 is 2 times 2. Those are prime. And remember, to get out of the radical, they need a partner. So this will equal, these two 2's partner up. They break out. Only one of them makes it. And that 3 cannot break out. So it stays a rad 3 inside the radical. That doesn't really look like a 3. And then don't forget this negative. Ooh, this is just too big of a highlighter. This negative right here. What is happening? What's happening? It results in an I. An I that I was very careful not to put in the radical on accident, okay? And this is the perfect answer forever and ever. But it is okay, just for this year, if you want to write 2I rad 3, okay? But again, that's not proper form. We need I to be at the very end. Okay, let's go find some true statements. Is I equal to the square root of -1? Yeah, that's like literally the definition of I. All right, somebody made it up and said that's what it is. The square root of -1 is an example of an imaginary number. Yes, it is, because it's I. Anything with I is imaginary. And this is equal to I. I squared is -1. Yeah. It is. We learned about this. Now, this isn't completely a definition. This is something that we can calculate. If I is the square root of -1, if I square both sides, I get that I squared equals square and square root cancel, -1. So yeah, that's true. That's actually very true. This is an important thing that will come up when we're simplifying expressions. So make sure, just as well as you know that I is the square root of -1, know just as well for me that I squared is -1. All right? Those are like the imaginary number fundamentals. Radical 3 is an example of an imaginary number. No, I don't see an I. I don't see a negative in a square root. That's not imaginary. This number is real. Don't you tell it that it's not. It's real, okay? What it is irrational. That means that it's a decimal that never repeats and goes on forever, but it's not imaginary. It's very much real. The solution of x squared equals 25 are imaginary numbers. I'm not really buying it, you guys. Take a look. Square root both sides. And we get x equals plus or minus 5. I didn't run into any brick walls. I didn't get any negatives in a square root. No, it's not. Okay, now we're going to solve, all right? X squared plus 100 equals 0. We first subtract the 100. We next square root both sides to get that x equals plus or minus the square root of -100. The negative is going to be an I, and that 100, square root of 100 is 10. There we go, boom, done, okay? Now, if you're confused on number 7, it's probably because you didn't watch when I did number 1. Go back to number 1, I do explain it in more detail there. Okay, number 8, solve, okie doke. First thing, 7 is times x squared, so I must divide it. It goes away. X squared equals -4. Then we square root both sides. And we get x equals plus or minus. And now we got to see what's going on here. This negative in the square root is going to be an I. And then the square root of 4, that's 2. Man, we are crushing it here, guys. Subtract the 19, step 1 of this guy. Remember, we need to get to x by first eliminating everybody on the outsides, the furthest out, all right? Furthest out, that 19. 2x squared equals 7 minus 19, negative 12. Okay, then we divide both sides by 2, divide both sides by 2, and this cancels, and I have x squared equals negative 6. And now, square root both sides. X equals plus or minus. That negative in the rad is going to be an I. And then the square root of 6, that's not a perfect square. It's also not prime. You could do a quick check. 6 is 2 times 3. But you'll see nobody has a partner to break out with. So this is just square root of 6. Okay? See how careful I was for my I not to appear to be in the radical? Okay, now remember, if you want to do that, it's okay this year. I doubt anybody in pre-calc or calculus will accept it this way. We need I to be the absolute last part to be proper form. Okay. Here's the graph of g of x. Which translation of g of x has imaginary zeros? Oh my gosh. Here they come with the first chapter stuff. They're just throwing it right back at us. So this is g of x. If g of x were to, what's happening here? Move up 4. So here is the vertex. If it goes up 1, 2, 3, 4, and it's still opening up, we got no x-intercepts. That means that it has 2 imaginary zeros. Okay. Okay. Minus 4. If I bring this down 4, 1, 2, 3, 4, minus 4 means down 4. It's still going to have 2 x-intercepts, you guys. It's still going to open up and eventually have 2. So it's going to have 2 x-intercepts, 2 real. So that means no imaginary. Okay. F of x plus 4 in the parentheses. This is left 4, if you remember. And I'm sorry, if I move this guy left or right, the x-intercepts will be further left or further right, but the number of them will not change. These both still have 2 very real x-intercepts, which means no imaginary. Okay, so which one has imaginary? Long story long? That one. Write a quadratic equation that's going to have these solutions. Oof. This is where we gotta think a little and work backwards a little. If my solution came out to be positive 5i, negative 5i, that must have been like a plus or minus 5i situation, which means in the previous step, I see that plus or minus. That means I square rooted both sides. So I must have had x squared. And then I must have had negative 25 in order for it to come out this way. So I had x squared equals negative 25. That would have these 2 solutions, 5i and negative 5i. Right now, you could call this a day. All right? But if you wanted to make it a little nicer, you could add the 25 to both sides and say y equals x squared minus 25. Or, you know what? The y doesn't really make sense. Sorry, I did that. 0 equals x squared minus 25. I don't know. Whatever you want, you guys. Both of these are technically equations. Both of these have solutions 5i, negative 5i. Okay. Now solve each equation algebraically. This is the spiral review. I don't really feel like doing all of it, you guys. So let me show you. I'm going to skip this one because it's like this one, but it's missing the first step of dividing by 4. So now see, these are similar. You solve them the same way. You square root both sides, you get a plus or minus 5 here. You get x minus 6 here because the rad and the square. Then you add the 6 to both sides. Can't do this, guys. Please don't. No, not 11. I need you to split these up. I need you to say that x equals 6 plus 5 and x equals 6 minus 5 so that you can get 11 and 1. So when the numbers are able to be added, we need to immediately break them up, okay? This guy right here, I would try to factor it. What multiplies to -8 and adds to -2? I'm thinking 2 and 4 with a -4 and a +2. If you are struggling with the factoring, I have a separate factoring video, go look for it. But this checks out. This means that x minus 4, x plus 2 equals 0. And now I can solve this with x minus 4 equals 0 and x plus 2 equals 0. That means that x equals 4 and x equals -2. Okay, show your thinking. These steps are showing me your thinking. Okay, so that's it for 2-6. Catch 2-7 in the next one.